Deci bine ați venit din nou, începem sesiunea numărul 2. Am avut deja o sesiune în prima parte a zilei, tot online. Vreau să fac o introducere scurtă despre noi. Trebuie știut, acum vorbesc pentru participanții care sunt pe Zoom. Suntem firma Reflex Software, avem soluții top pentru studenți sau ingineri, viitori ingineri entuziasmați. În portofoliul nostru se află programul IDEA StatiCa, avem soluții pentru structuri metalice, structuri de beton, de orice tip, avem constilul și promovăm proiectarea parametrică. Astăzi vom dedica a doua parte a zilei programului IDEA StatiCa. Suntem la Facultatea de Construcții din Timișoara. Facem un workshop împreună cu studenți și cu participanții care sunt acum pe Zoom. Și dau cuvântul mai departe la domnul profesor Noi să fac o mică introducere, recapitulare ce vom face astăzi.
Bună ziua tuturor și mă bucur că ați venit atât de mulți la această prezentare. Sincer să nu am văzut niciodată la nicio prezentare atât de mulți studenți, dar mă bucur. Ce vom face azi? O să aveți o oglindă de beton pretensionat cu armătură preîntinsă. Veți face introducerea datelor, definirea elementelor principale, toroanelor, după care veți face calculul pierderilor de tensiuni, veți interveni unde va fi nevoie. Asta va fi în principiu în prima parte. În partea a doua se va axa la verificarea elementului, la eforturi sau încărcări suprapuse de momente încovoitor, forțe tăietoare și torsiune. Se va pune accent pe verificarea elementului pentru aceste solicitări suprapuse și în special ce nu facem noi la partea de nici la partea de curs, nici la partea de proiect, ce se întâmplă dacă se schimbă clasa de expunere. Din cauza clasei de expunere ați ajuns deja la faza aceasta de proiect, în ultima fază, când suntem în faza ultimă. Este foarte important când facem verificarea în ce clasă de expunere ne aflăm, permitem sau nu permitem dezvoltarea eforturilor de întindere la partea interioară a grinzii. Și aici vin tot felul de verificări mult mai complexe și în final să sperăm că vom avea suficient timp. Se va face și o prezentare la un element supus la torsiune cu toate aceste probleme specifice și să sperăm că o să avem puțin timp și pentru partea de detaliere. Vă rog frumos, dacă aveți întrebări, să adresați cu încredere. Dacă cumva nu înțelegeți ceva, vom încerca să vă traducem. Dacă nu puteți să puneți corect întrebarea, vă ajutăm să punem. Ideea este să înțelegem cât mai mult din acest program. Dânsii s-au oferit, după ce se termină cursul, să vă pună la dispoziție înregistrarea cursului și asistență până când terminați proiectul. Mă bucur că ați venit și spor la treabă atunci.
Thank you. It will be in English. First of all, I have no idea what they told you. And so I have prepared my own presentation, my own introduction. And so give me a second. I will just share the screen. Yes, you can see it. Like that. So let me introduce ourselves. I'm Thomas, product development engineer from IDEA StatiCa, and I will spend, let's say, few hours with you, 3 hours, and we will design a simple beam which will be pre-stressed. It will have the rotated T-shaped cross section. And the second person who is with me is Lukáš. He is here. He had the first part before the lunch. He just proceed because nobody from the online session cannot hear you. Yeah, okay, thank you. Okay. He just told me that nobody can hear me if I'm standing, so I will sit where I am. So this is Lukáš. He had the morning part. He designed prestressed beam, very like pretty much the same we are going to do now, but with openings and with kind of let's say more complicated stuff in our other application. I will introduce you later on, and he's here mainly to help you with modeling, because we are going to do the example together. You have your laptops. I suppose that you have your own license, trial license or edu license. If not, we can solve it. And so if you have some problem with modeling or some like quick question, you can raise your hand and ask him. He will be walking here, and he's a nice guy, very helpful one. So about the content, I will do a quick introduction, about 10 minutes, let's say, about our company, what we do, what is our software about. Yeah, just to introduce you, what is it for, where can it be used, etc. Then we will do the first part of the modeling of this prestressed beam. It will be focused mainly on your design guide, because your professors sent me your design guide. So I'm going to focus on some parts of this design guide, and I'm going to show you where you can input all of the things you have in your design guide, like I don't know, the strength of the concrete after thermal treating and stuff like that. Then we will have the coffee break, and in the second part I would like to focus on more let's say practical things, focused on things that you didn't do in your courses. Yeah, because I guess that there is no time for it. I'd like to show you some interesting things about the application, about the solution itself, what problems you can have in practice, and how to solve them, etc. And then I really hope that we will have a discussion. Yeah, let's leave time for it. Let's say at least 15-20 minutes of discussion, it would be fine. So if you have any question, prepare them, and at the end or before the coffee break, we can go through them. I hope that I will be able to answer them, all of them. And as I said, it will be about 3 hours, including the coffee break, of course. So before we start, there are some links and addresses. The first address is where you can download IDEA StatiCa software. If you didn't do that, you can find the installation files there. The second 2 rows is the license name or password. Please just try to run or launch any application, any module in IDEA StatiCa if it works for you. If it's not, you can use this license name and password. It's valid only for today, for this session. Or if you will have problems with the license during the presentation, just ask me or Lukáš, and I will show you this license name and password again. And the last one is the most important one. Please do it now. There is also a QR code for this link. This is the place where you can download, and you should do it, auxiliary files, which we will need for modeling. Because I'm not going to input all of the things with you one by one. We will import them. So there are some text files for import and stuff like that, and complete designed beam file, etc. So please go to the last web page, ideastatica.com/support center/Timișoara, and download the files for afternoon session. So do you have these files downloaded, or is there any problem? Yeah, so I need to continue.
Hey guys, we stated, also if you are in channel communication, what the boss is doing, you can just open it up and check it goes.
Yes, we will have some checkpoints where we can like correct our models and have them the same.
And you hesitate to ask, we are other teachers, we are. Yeah, you hesitate.
So let's start with the introduction. It will be just about us, who we are, just for you to understand who are you talking with, stuff like that. We are IDEA StatiCa, company from Czech Republic, and our main focus are steel connections, concrete details, and general members. There are some numbers. We have, I don't know, thousands of customers, but I think for you it's not so like important. But what is important is where our software is placed in the toolkit of structural engineer. Just to understand what is it for. We think that each structural engineer needs to have 3 kinds of software. The first one, we call it CAD software. It is for drawings mainly. You know, AutoCAD, you know, Revit, Tekla structures. I mean, this kind of for drawings, for modeling, geometry, etc. The second software is the FEA software for global analysis of your models or of your structures. You know, in your territory, it would be sub 2000, most used one, I guess, or robot maybe, sophistic, for very complicated structures, ETABS, and softwares like that. So once you have your structure modeled, once you know the geometry and have the drawings, you have the global analysis, you have the results like internal forces, etc. You need to do code checks. You need to say if these internal forces are too much or it is okay. Do I have enough reinforcement in the structure, etc. And that's the place for IDEA StatiCa. That's our focus. We focus on code checks, on details, on complicated problems, D regions, critical members, and stuff like that. So we don't compete sub 2000. Yeah, we are like complementary for them.
Okay.
Hmm?
What softwares are you using for global analysis? Acest, VM, what software?
Acest, probably, I guess.
I'm
Yes.
just asking.
So who has experience with Acest?
They don't use.
They don't use.
Yeah.
They didn't use it. They will use them. Okay. So where we are, yeah. IDEA StatiCa portfolio for concrete. In the morning session, it was mainly about beam and detail applications. I will start with detail, but we are not going to dive into this application, but just let you know what is it about. This detail is for so-called D regions. That's basically the regions in your structure where you have really problem, like huge openings, depth ends, rapid change of cross sections, etc. But we are not going to dive into this application. What we are going to do in this lesson is, or are, beam application and RCS. RCS means reinforced concrete section. These two applications are tied together. We will primarily work with beam. You can guess what is it for. It's like very easy. And then we will go to RCS to check the cross sections in the beam, in the middle of the span, etc., etc. Then we also have member. The main purpose of this application are, let's say, stability issues. If you have, for example, very slender columns, you can calculate second order effects and stuff like that. And we have also checkboard for beam links. So you can interconnect, for example, sub 2000 and IDEA StatiCa together and send information, for example, from this sub 2000 or from Acest to our applications. So, as I've just said, we are going to work with beam application. But the question, of course, is what is it for? It is for straight 2D, or it can be for polygonal beams mainly. It was developed for 2D FEA structural analysis, but what is important, you can model single or multi-span beams, including time-dependent analysis. It means basically that you can define construction stages like prestressing stage, transport, storage, and start of working life, end of working life. You know, you have had this courses, so you know that there are some issues with creep, for example. It is different at the start of the working life. It's different at the end of the working life. There are some issues with shrinkage, etc. So this application is for it. And once we have this time-dependent analysis, it means that it would be handy to have prestressing in it. And it is there. You can model pretension, wires or strands, and also post-tension tendons. I know that you have done only pretension beams. Am I right? Yes. And there can be also the combination. In the picture, you can see the bridge, pre-span bridge, which was done from prefabricated beams and which was connected together with the post-tension cable. It can be seen here. Yeah, this cable was added at the construction site. So these are the capabilities, some assumptions, just to better understand what this software is about. We are dealing with 1D finite element model. I know it can be hard for you to understand it. You can imagine that we define only the straight lines with nodes. Nothing 2D, no plates, no decks and stuff like that. The analysis is linear. It means that it's basically easier to calculate it, but we have nonlinear reflections. It means that it is influenced by cracks, it is influenced by shrinkage and by creep. Yeah, because these long-terms, deflections are usually higher than the short-term deflections. And what we can also calculate in this application is redistribution and reduction of internal forces on hyperstatic beams. I mean, if you have more than 2 supports, like more than simple beam, you can calculate these kind of redistributions according to the Eurocode. And the RCS application, that will be the second one we are going to touch today, is the application which is incorporated in Beam. So you can send the data from Beam to RCS and vice versa. And it is mainly for 1D section check of reinforced, composite, and pre-stressed cross sections. We have also a module for 2D checks. It's for decks, and it's about Baumann method. Maybe you will hear about it. You can just remember that there is something that can help with this Baumann method. What is important to know is that both of these applications are strongly code-based. So you can calculate only according to Eurocode in it. But in Romania, Eurocode is valid and is necessary to do it. So it will be for you. And we can deal with ultimate limit state and serviceability limit state. It means that I will show you how to calculate, for example, crack width or stress limitation checks and stuff like that. Now, that was the introduction, and let's move on and let's start with the workshop itself. So, give me a few seconds. I will prepare my computer for that. Sorry. So this is the application. This is the application, and I need to prepare some materials for me. So please go to the concrete part here. And launch a beam application. You should see something like this. The resolution here is not so good, so we'll see how it will look like. The application itself, I hope that it will be readable. So professors told me that you will, after you finish your project by hand, you will get 8 from 9 or something like that. And if you do it in some commercial software like IDEA, you will have 10. Is it true? 2? Yeah. 2 points, additional 2 points. That's fine. That's great to hear, because this initiative is fine. To know the theory and to know how to calculate it by hand is the one thing, but you need to do it in practice quickly. And for that, you usually need very good Excel spreadsheets or some commercial software, for example. So do we have it? Can we start? So you may guess that first what we need to do is click on the new button in the top ribbon, in the top left corner, and something what we call yeah. Okay, so Lukáš just asked me to show you again the login information, so I'll do that. So again, the login. So if you need it. Yes, thanks. So this is what we call wizard, where you can start with your design. This wizard will help you to create a model very quickly. So what we are going to do, we are going to do prefabricated concrete beam. So this option, we are going to do pre-stressed precast beam with the option of subsequent post-engineering. We are not going to do this post-engineering, but we need pre-stressed precast beam. We are going to do only single span, and you can leave these settings as I have. I think that's the default setting. Then you can click on next. And please switch it to the polygonal beam. We will work with it. I mean, I think in the second part. And the length of the beam, I have 11 meters, 0.17, so we can stay with it. And then click on next. And let's do the settings. This is, I think, the last one. We will use design code Eurocode. We are not going to use code for bridges, national annex. Let's leave the general one, 50 years. Now, what is important, we need to input the cross-section. So click on it. And we will use this rotated T-shape. It's in basic cross sections, and the values would be, the height would be 1 meter and 100 millimeters. The width is 800, then 400, and then 300. So here you can see the shape. It should look the same as I have, and C25 is very low concrete for pre-stress beam, so we will change it. So let's click on these green arrows the database of materials will be opened and we will select C50/60. So, so we have the cross section, click on OK. And the last thing, we need to set permanent load and variable load. Let's input pretty high values to see some great results. So permanent will be -85 and variable will be -45. Then I'm going to uncheck critical load patterns. Let's leave it and we will have the summers, yes. So it should look like that. And once you have it, you can click on next.
Can you show the cross section, please?
Of course. Oh, sorry. No, in that way, I have it here. Give me a second. So here is the cross section again. So during this presentation, there will be some modeling parts like that. Then we will stop for a while and I will be talking about the inputs, what does it mean, etc. So don't be afraid, it will not be for the whole presentation like that. So, and click on next, and we just need to set some construction stages. So yes, I have it here. Please rewrite this cell to 0.5 and this cell to 0. It will define the supports during the construction process. You will see it graphically immediately in the software, and I will show you what these numbers mean. It doesn't actually matter what you have here in times or other things, but it would be nice to have these numbers the same as I have, because we are going to change these times and we are going to work with them a little bit later on.
Na cíle nastavení myši, ať tam můžeš dát takovýto kolečko, kterým klikáš, aby oni věděli, že kde seš, protože to se strašně ztrácí na té myšce, takže přes mouse settings. Jo. Že to je? Mouse settings, advanced settings, mi ukazoval teďka mistr mouse settings. To ne, to já, no. Takže přes normálně settings, mouse settings, zkusím psat. No v češtině, nastavení myši, no. Okay. Additional settings. Tady dal pointer. Options, jo. Pointers, ještě pointers. A tady mělo být, že si něco vyber a enable it pointer. Byl jsem to kolečko nějaký. Já to vidíš. To je tohle, ne? Počkej.
So, do we have it? Can we continue? So, oh, I didn't find it. It doesn't. So once you have it, you can click on finish, and we will have the model predefined.
Pointer options. So if you hit the control,
I know.
and that's all.
No, do that. So, and we can click on finish, and the model will be created.
Vždycky si jich třeba po párkrocích zeptej, jestli stíhají. Říkal ti to, jo? Jo.
So this is the model. This is the model in 3D, and now I will introduce the interface of the application just to know the nomenclature. So this is the top ribbon. Sorry, this is the top ribbon here. This is the navigator. Yeah, so when I said in the navigator, it means this left part. This is the main screen. I can say the scene where the graphical input or output is. And below that, there is a data window for inputs and for additional information. So in case you do a mistake at the beginning in the wizard, you can go to the data, to the project data and change it. Project data is the first item in the navigator. So we can go through it, what we have here, and you can see that everything can be changed after the wizard. The wizard is there mainly for the quick creation of the model. So before we start with tendon design, I'm going to mention something about construction stages. Yeah. The first thing, what you have in your design guide was how to calculate cross-section characteristics. If you go to material, this is the third item in the navigator. I'm sorry, cross-sections. You can go here to characteristics and you have the results here. So you can check if your head calculations were correct or not. So here are the cross-sectional characteristics of this rotated T-section. In cross-sections in navigator and in characteristics in data window. The second thing you have in your design guide is the calculation of the concrete strength in time of transferring of prestressing. I mean, you have the thermal treatment curves. You need to calculate beta factor. From that, you need to calculate equivalent time according to equation B10. I will show it very soon. And from that, you need to calculate the strength of the concrete in time of prestressing. So how to do that in application? If you go to construction stages in the navigator, I will modify my screen a little bit. and select the transfer of prestressing stage, which is the second one. I will try to do something with the resolution. Just give me a second. It's very bad. Maybe we can try it like that. Ah, it's better. It's much better. Good. So where we are, in construction stages here in Navigator, you can select the transfer of prestressing stage. And we have three values here. We have the time, and we can, for example, check this user specified concrete strength. Let's rewrite it to 35 megapascals. And this is it. Based on the thermal treatment curves, you need to calculate beta factor and the strength of the concrete at the time of prestressing. So you will have the equivalent time from that. This is this time, calculated based on this number. Or you can simply input the value of the strength of the concrete manually. Sorry. Does it work? Yeah, it works. Okay. So that's it. So to remind what I mean, this is this equation you'll have in your design guide. And this equivalent time is basically this time. Or from the perspective of structural engineer, of designer, you know that in time of prestressing, I need this strength of concrete. I don't care about times. It's up to you how you create your concrete. Yeah, so you can do it like that to input the strength of the concrete, not the time from this equation. And based on these values, the creep and shrinkage is calculated, and it's done automatically by the software. Later on, I will show you where you find all of these results, where you find the creep, where you find shrinkage, all of these creep coefficients in the particle types, where you find all of the inputs for shrinkage, etc. So that's the first important thing. If you want to set the time or the strength of the concrete, go here to the construction stages. And now let's move on to the tendon design, tendon input. You can access it from the top ribbon, and the tendon designer will be opened. So click on it. So this is the tendon designer. First, what you can see is the graph or the chart of our construction stages. Yeah, first stage is the self weight. Second stage is pre-tensioning and some like additional weights and rheology, etc., etc., etc. And this is the end of the life. And here are the times we have input. So let's set some tendons. So go to tendons, to tendon layout in the navigator. You can see that it's completely empty. And we will input some of them. So the first one can be pre-tangent on edge. Like this one, in the top ribbon. So select the pre-tangent on edge in the top ribbon. The tendon will be added automatically with some default values, and we are going to change it. Before we start with the geometry, let's rewrite the initial stress. this initial stress is the stress you have on the stressing jack. So for our example, it would be 1,400 megapascals. And I'm going to show you where you can select the material for the strands. The default one is that one. Again, we can click on the green arrows and select from database some material. Your professors told me that you can use in your project, for example, this one. No, sorry, this one. Why 1860 S7 15.2. In your project, I will show you what I have from your professors. It looks a little bit different, I know.
is like the encouraged price. And the materials, you can see that, and the material.
So from your professors, I got this kind of definition. So it's 0.6. What is it? And it should have the area of 140 millimeters. These materials are from the database of Eurocode. Of course, you can create your own material. I will show you where you can define all of these inputs. So we will select this one. If you cannot find it, it doesn't matter. We will at the end input all of the tandems with and change it again. So we have the first tandem with this material and this initial stress. And let's go to the second tab in the data window to prestressing group. And we will define the geometry. So I will define. We will have two of them. And from the here, come on. Sorry. The cover will be 60 millimeters. 60, not 6, sorry. We will have 350. Oh, it's too much, sorry. 150. And 150 for the second. And you can play with the geometry. It's not complicated. I think you can see how it is changing, why I rewriting the values. You can select the number, the edge, the position, etc. Don't waste time with proper like inputting. We will import it at the end. I'm just showing you where you can and how you can define these tendons, these cables. If you want to do it for your project, you need to do it according to your design, of course. What is important is this blanketed length. We call it also separation. It means that you define the length where the tendon will not be connected with the concrete. Yeah, you have it also in your projects. So we can set something like can be 1.5 meters or something like that. 1.5 meter and 1.5 meter. It's graphically shown here. Maybe you will see it better on your computer. This is the blanked length. And you can also switch the view to the cross section here in the top ribbon and define the position of the cross section. I will zoom it a little bit. You can see that in the position of 0, it is separated from the concrete. And in the position 1.6 meters, it is not separated. So that's the way how you can check if your input was correct or not for all of the tendons. And, but now we will import the rest of the tendons because I don't want to spend much time with the input number by number. So let's click on the import in the top ribbon.
Guys, we are recording for the thing, so we will get the recording from that session. So if you don't get something to be ready, so we will get the recording.
So go to the import and click. Sorry. Before we import it, just delete all what you have just created, because import works that it adds a new cables or new tendons. The old one will stay. So first we need to delete all. So let's do it. In the top ribbon again, delete all and click on import, import new tendon from txt file, and find your txt you have downloaded at the beginning of the session, and it calls tendons, and just import it. And we can click on open, and you will see that the tendons, including blanked length, separation, will be imported. We can check them here. So, yeah, I know. So do that. And please rewrite again these initial stresses and switch the material. So the material should be this one, and initial stress should be this one. If you want to switch the view to the previous one, you can go to this uncoiled, or you can change it in you can check it in 3D view as well. The views are here in the top ribbon. I will go for the uncoiled, or maybe for the cross section. And we can check the separation or the blanked length. In 3 meters, there is no separation. In 2.1, few of tendons are separated. And in 1.1, for example, more tendons are separated.
So from where to import the tendon?
Yeah, the tendons, the button is here in the top ribbon, import. And you have downloaded the file, the text file, it calls tendons. So select the file tendons after you click on this. Yes, I will again show where to download it. So this is the address where you can download it. Download these files. And what about online participants? Do you have any questions? Is everything clear from the point of view of modeling? So the result should be like that. Tendons. So Lukáš will be gradually helping you, and I'm going to continue. So we have the geometry of tendons, we have initial stress, and we have the material. Now we need to set other things for the prestressing. So let's go to design member in project data. And in design member, there is a way how to modify the stressing bed and what is about or around the stressing bed. We are going to define slip, we are going to define thermal losses, we are going to define, for example, the time before the time for relaxation, which was realized before the concreting, etc. Maybe I forgot to mention that you can modify your material for tendons by clicking on this blue pencil, and if you need, you can like select all of these things like relaxation class. I think that you have different in your projects. It differs for everyone. Some of us have class 1, and some of us have class 2, etc. It is the definition of the area again. We went through it. And if you are not satisfied, or if you want to modify your relaxation based on some inputs from, I don't know, the company, from the technology for concrete, etc., you can create your own exposure. You can create your own relaxation tables, relaxation curves and functions here by clicking on this by user table. It can be also handy for your project. So, but let's leave it according to your code, and let's move on to design member and click here on the pencil button for this stressing bed. There are some settings. We will stay here for a while, and I will explain what can you set here and what it influences. So I will rewrite the numbers to have numbers I need, and I will gradually explain what they are for, and sudden release. So I have a slide for that. It would be better. This is this slide. So what we have in the settings, the first item is the length of the prestressing unit. You know, from your design guide, you know this formula, and this is this value of LP. This is for calculation of loss due to slip. These values for the slip can be set here as anchorage set slip. These are both together. So, and also for that kind of loss, according to equation 10.3 from Eurocode, you can select the temperatures here in this setting. This code coefficient is basically this number, is 0.5. And the sudden release can be set here. It is for these coefficients to calculate this LPT transition length. And for the transition length, from the transition length, you usually calculate your how it calls the dispersion length. Yeah, so all of these inputs can be done here. So let's set it. Sudden release 15 meters, and there is also the how it goes, a correction of relaxation. I set 0 seconds because some companies can, let's say, can hold the maximum stress on stressing jack for some time, and it can reduce the relaxation in the tendons. This is the technique how to do that, but I noticed that you don't have it in your design guide, so let's leave it for now. We can discuss it during the discussion at the end. I can draw you how it works, how the time can be calculated, etc. So let's stay with this setting and click on OK. Now we will move to prestressing losses and to the part of tendon stress / losses. So you noticed that the inputs were very easy. You just need to know where to input what number from your design guide. Yeah? Nothing special, few numbers. And the geometry, of course, that was a little bit complicated. Now you need to know the losses. You know that there are a lot of equations in your design guide, a lot of methodology behind. But in the software, in the practice, you need to do it quickly for all of the use cases. You don't have usually time to find the proper equation in the Eurocode, etc. So that's why we added this part of the software, and that can tell you all of the losses, or that can show you all of the losses calculated by one click. You don't need to care about the equations. You just need to know that, hey, I need this kind of losses, anchorage set loss. I need this kind of losses, which is loss due to deformation of abutments, etc., etc., etc. And at the end, yeah, I need to calculate the model first. Sorry, it's on the top ribbon. Please click on it and let the program to calculate it. And after that, you will see the stress at the beginning of life, stress at the end of life, etc. Yes. And I forgot to mention one thing. Sorry. So I will go back to my presentation and to the setting we discussed. To this setting, and this is the duration of short-term relaxation, and this is this equation. You have it also in your design guide, so you work with it. This equivalent time, you can read what is it for. It needs to be added to the time for relaxation that is happening before the concreting. So the final time for relaxation must be set here. Yeah? And now we need to go back to the construction stages and realize what we have. We have one time for concrete that defines the strength of the concrete in time of prestressing. And then we have the second time, this time, that defines the relaxation that happened before the concreting. Yeah, and these times can be different because of thermal treating. Yeah, these are not the real times. This is always the real time for example, real time plus this equivalent time from this equation. Okay. But according to my experience for practice, yes, it matters, but the influence is not so high or not so big. Yeah. You deal with like more complicated or more the problems that are harder to solve. I will show you in the second part what are the usual problem of the structural engineers, of the structural engineer, according to my experience from practice. So that was the last number. Yes, we have the model calculated, and we can take a look at the losses. For each tendon, you can select tendons here in the navigator. We have 8 tendons or 8 strands defined or imported from the text file. So for each tendon, oh, this is the same as the previous one. Again, this is without the separation, without the blanketed length. This one have 2.5 meter blanketed length. Yeah, okay. And yes, you can find all of the numbers, all of the losses, all of the stresses in these tables. If you don't know what the number means or what is this loss, there is always a tooltip that will tell you what is it about, where you can find it. Usually there is also the link to the code, etc. For those who were with Lukáš in the morning, this is the stress. The sigma PM0 is the stress you need to input to detail as a stress. Yes. Yeah, so you can pre-calculate it, this stress, for example, here in the beam. This is the transition length, you know, from your design guide, LPT. Everything is calculated automatically, of course, because this is the software. So we have strands, and now I will show you in force design. You can go to the linear elastic stresses. Please go there. And click on calculate. And now you can see the maximum and the minimum stress through whole of the beam. So the maximum linear stress, which is very important, it's without cracks and without the exclusion of concrete in tension, is 5.4, and the minimum is -20, if we did it correctly. But the question is based on what? We input only permanent and variable loads. And what about combinations? What about other calculations? Where it is? Yeah, I will show you, because according to code, all of the combinations that are necessary for the design are created automatically. You can, of course, control them if you need. If you need, for example, add another variable load. So let's exit the tendon designer by clicking on this button. You can see that there are some new items in the navigator, like results, internal forces. So I will go for uncoiled view in the top ribbon. You can select transfer of prestressing construction stage and all characteristic combinations, and you will see bending moment, etc. And here you can go through all of the stages, all of the combinations, all of the load cases, and display deformations, internal forces, and reactions. So it will be time for coffee break, but before that, let's take a look at the combinations in the navigator. It's the last item for loads. And as you can see, all necessary combinations for Eurocode are predefined, because we know that the permanent load we have input at the beginning will be added at the start of working life, and the variable load will be added at the start and at the end of working life. Yeah? I will show you if I go to construction stages, to the superimposed load. Oh, it's not there. So sorry, to load cases. Am I right? Yes. If I go to load cases, to G5, you can see that the uniform load is already input. And this G6 means it's the 6th construction stage. G7 is the last one. Yeah, G7 is the end of working life, and G6 is the start of working life. So we have this value here as a uniform permanent load, and there is Q load case, which represents variable load. It was created automatically, and it has the value -45. Yeah. And here is the place we will speak about it later on after the break, a little bit more how to control it. And this is the place where you have your loads, and in combinations based on these inputs, these combinations for characteristic, frequent, quasi-permanent, and fundamental ultimate limit state combinations were created. You can edit them, update if it is needed, and you can create, of course, your own combination if it is needed for your design. So let's do the coffee break.